Let's move on to our final t-test now. It is our dependent, or as I mentioned before, often called matched pairs. In fact, in SPSS, when we go to run this, you'll see it's called matched pairs t-test. And the reason being is, as you'll see here in a second, the data are somehow matched or related. Okay? So, how do we know when to use dependent t-tests? Well, as we said before with all of our t-tests, if you are trying to compare two group means, we know it's some type of a t-test. As with the independent t-test, in this case we don't know mu, so we're going to have two samples. But as opposed to independent t-tests, in this case the data or the observations are somehow related or dependent on one another. Again, this could be repeated data from one person where you have like a pre-test and a post-test, or some other type of matching. So take this example that I have here on the screen. Let's take this scenario. We've got a licensed marriage therapist who believes that husbands are generally more satisfied in the marriage than the wives. And in order to test this, the therapist recruits 8 different couples to take a standard marital satisfaction test that range from 0 to 32. We've got the data below. You can kind of look and see what you think, sort of eyeballing it. But again, as we've done before, we want to know, is the therapist's hypothesis correct? Okay, so let's look at this. How do we know this is a dependent t-test? Well, we have two groups here. We have a husband and we have a wife. Now, we don't know what the mu is on this standardized test, so we don't have anything to compare it to other than these two scores. So we know now we're dealing with either an independent or a dependent t-test. But now we're going to say the observations are related. Why? How are these observations related? Well, if you think about this, we've got a husband and a wife who are rating the same marriage. So you've got two people who have some sort of connection rating the same thing. And so in this case, we would say this qualifies as observations being dependent. It's two couple or a couple rating their similar relationship. Hopefully that makes sense. If not, we can talk about this when we get to the face-to-face portion of this. But in either case, it is a dependent t-test. So get out your 7 steps. We're going to walk through the NHST for this example. Okay, first thing, we write our hypotheses. Hopefully you're getting good at this, but we have the null where we find that the population for the husbands is about the same as that for the wives. In other words, there's no difference in their marital satisfaction scores. However, we have the alternative hypothesis where husbands have a lower marital satisfaction score on average than the wives. And then our other alternative hypothesis, and this is the one that is being projected or hypothesized by the researcher, in this case, believing that husbands have a higher marital satisfaction score on average than the wives. Okay, and you'll note the asterisk there again, indicating that that is our preferred hypothesis, or the one we believe will be the case. All right, step 2, we're going to pick the test. In this case, we're doing a dependent t-test because that's where we are, so we can move on to number 3. Number 3, again, we're going to assume an alpha of 0.05 because we weren't told any differently. Now, we need to calculate the degrees of freedom like we have for our other t-tests. In this case, for a dependent t-test, degrees of freedom are the n of our pairs minus 1. So in our case, we know that the researcher or the therapist recruited 8 couples. They are matched pairs. So that's what we mean by the size, the sample size of the pairs. There are 8 pairs, minus 1 gives us degrees of freedom of 7. Okay, 8 pairs minus 1, 7 degrees of freedom. So again, we can look at our t-table, two-tailed test at 0.05, follow the column down to 7 degrees of freedom, move over to the 0.5 level, and we get our t-critical of plus or minus 2.36, okay, with an alpha of 0.05. Go to step 4, we want to actually conduct the analysis. Here is the output that you will see for a dependent t-test with SPSS. Again, note our basic descriptive statistics are in the top box just like they have been in the past. We see the mean satisfaction score for the husbands, it's 21.5, and we see the mean satisfaction score for the wives, it's 15.5. I want to make a note here. Yes, that is different. The question is that likely due to just random sampling error, or is this a statistically significant difference? That's what we're testing. Is that significantly different? We see that the n in this case is 8, okay, because that's the pairing that we have. We can also see then the standard deviations for both the husbands and the wives, okay? You can go on down. There's that paired sample correlation, which we're not going to worry about at this point, so you can skip over that and go to the third box. And this is where our important information is. And you'll notice that it provides the pair. Okay, so we see a mean value there of 6. That is the mean difference. It's husbands minus wives. So the husband's score was 6 points higher than the wives' score. We see the standard deviation of the difference there, and then the standard mean, which we're not concerned about at this point. Then we see, in this case, SPSS output kind of switches things around a little bit. It starts with our 95% confidence interval, and then it gives us our t-test degrees of freedom and significance. So let's go over to the t-value. What is our observed t-value for this particular sample? We have a t-observed that equals what? What is the actual value? It is 5.02. Okay, that is our t-observed value. We know it has 7 degrees of freedom, which we've already discussed that. And what is our p-observed value here? Our p-value equals, again, it's that final column over here that says significance two-tailed. That's SPSS vernacular for p-value. In this case, it equals 0.00, getting ahead of myself here, 0.002. So as I have encouraged you to do all along, let's put this where it would be on the chart. If this is 0.025, where is 0.002? It's going to be somewhere out here, way out here. And let's just say somewhere right there. So if this is our p-value is 0.002, is it in this shaded region? Yes, it is. Hopefully, though, you are seeing less of a need to do this. Why? Because we can look at this p of 0.002 and compare it to a p of 0.05. This is our standard. Is this less than 0.05? Yes, it is. Therefore, we can conclude that there is a significant difference. Now, how do we write that up? I don't want you to just tell me there is a significant difference. I am looking for you to tell me what that significant difference is. So a sample write-up, as we're moving a little further, by the time you get here face-to-face, we're going to have a more full-blown APA write-up. But what I'm looking for is something like this. The mean marital satisfaction score for husbands, and then I want you to give me their values, was significantly higher than the mean marital satisfaction score for the wives, and then give me their values. How do I know that the score for husbands was significantly higher? Well, one, I know it's statistically significant, and in which direction now? I have to look at the mean scores. My husband means is 21.5. My wife's mean was 15.5. So statistically significant, husbands were higher than wives. And then at the end, I want you to put the APA notation for the statistic. In this case, T was 7 degrees of freedom equals 5.02, which is what we said, and P equals 0.002. The next thing we need to do, calculate effect size. For the dependent t-test, we are back to Cohen's d. So we're going to take our mean difference. Okay, in this case, we have to look at the mean difference. And if we go to that third box again where we see mean, I told you that was the mean difference. It's husband scores minus wives scores, which is 6. So it's 6 minus, and then in this case, the mu difference. This is the assumed mu difference, which most cases, the null is 0. So it's going to be 6 minus 0 over the standard deviation difference, which, again, look at that bottom box. In the second column over is standard deviation. That's standard deviation of the difference, and that's 3.381. Okay, just a little note. When we're doing calculations, keep as many decimal places as SPSS gives you. Once you're done with the calculation, then round to 2 decimal places. So if we take this, we can get out our calculator, and basically we're going to take 6 divided by 3.381. We end up with 1.77. So our effect size, little d, equals 1.77. Okay, is that small, medium, or large? Recall that small was 0.2, medium 0.5, large 0.8. This is greater than 0.8, so we would say this is a large effect size. Okay? I would ask if there are any questions, but since you can't raise your hand, I won't. Though I am sure some of you will have questions. Make some notes. We will answer this in the face-to-face section. If you're not getting it here, don't be overly stressed. We will cover this some more when we get face-to-face. All right, the last thing we want to do is note our confidence intervals. Again, SPSS prints this out for us, so all we're doing is transferring these. In this case, our boundaries, lower bound is 3.17, and our upper bound is 8.83. So again, we are 95% confident that our true population value is somewhere between 3.17 and 8.83.